celebrity divorce, political scandal, viral cat video, the same endless rhythm headlines competing for your attention, each one louder than the last. But there's something they're not telling you. Right now, something is racing through our solar system that shouldn't be here. An object that travelled through absolute darkness for longer than humans have existed. It crossed distances we can barely imagine just to sweep past our sun for a few brief weeks before disappearing into the cosmic deep forever. We've only witnessed 3 of these interstellar visitors in all of recorded history. This is the 3rd one. Its name won't trend on Twitter. No news anchor will mention it tonight. No breaking news alert will buzz your phone. In humanity's most connected era, one of the most significant cosmic events of our lifetime is happening in almost complete silence. The question isn't what's passing through our solar system. The question is, why is nobody talking about it? Welcome to the story mainstream media doesn't want to be complicated by, let's find out what happens when the universe's greatest mysteries meet the 24-hour news cycle. If you're ready to see what's really happening above your head, while everyone else scrolls past, subscribe and hit that bell. This is where cosmic events get the attention they deserve. And if you're already questioning your newsfeed, leave a like. Others are searching for this too. Picture this moment with me. You're standing in Times Square on a random Thursday evening. Screens tower above you, hundreds of them flashing, pulsing, screaming for attention. Sports scores update every 3 seconds. Stock tickers race across LED ribbons. A celebrity's face appears on a billboard 3 stories tall, promoting something you'll forget by tomorrow. The noise is overwhelming. The light is blinding. Information crashes over you in waves. Now imagine a single screen in the corner goes dark. Just one. Silent. Black. You probably wouldn't notice it, would you? In all that chaos, one quiet screen wouldn't register. Your brain would filter it out, focusing instead on everything that's moving, flashing, demanding to be seen. That's exactly what's happening with 3i/Atlas. In the cacophony of modern media where breaking news breaks every 15 minutes, where algorithms curate reality based on what makes you click, where outrage travels faster than facts, this interstellar visitor is that dark screen, present, significant, but invisible in all the noise. Here's what makes this silence so strange. When Oumuamua arrived in October 2017, the world went absolutely wild. You remember it, don't you? That cigar-shaped mystery tumbling through our solar system made front-page news everywhere. The New York Times ran it above the fold. CNN dedicated full segments to it. For weeks, you couldn't escape the speculation. Was it natural? Could it be artificial? Harvard's professor Avi Loeb suggested it might be an alien light sail, and suddenly everyone from morning talk shows to late-night comedy had an opinion about interstellar objects. Google searches for Oumuamua peaked at over 10 million in a single week. News articles over 15,000 published in the first month alone. Social media exploded. Reddit threads hit hundreds of thousands of comments. Twitter couldn't stop talking about it. The entire planet, it seemed, was looking up. That was just 7 years ago. Now we have 3i/Atlas, the 3rd interstellar object ever confirmed in human history. And if you Google it right now, you'll find roughly 200 news articles total. Not 200 this week, not 200 this month, 200 total since its discovery. Most of them buried in specialised science publications you've probably never heard of. On Twitter, barely a whisper. A few hundred mentions, mostly from amateur astronomers and space enthusiasts sharing data among themselves. TikTok, where everything goes viral, virtually nothing. Instagram silence. The algorithms decided this isn't worth your time. Let that sink in for a moment. The 3rd interstellar visitor in all of recorded human history, an object that originated somewhere beyond our sun's gravitational embrace, that carries secrets about the chemistry and composition of alien star systems, is passing through our cosmic neighbourhood right now, and it's receiving less media attention than the average celebrity breakup. Why? The answer isn't simple, But it starts with something media executives discovered decades ago: complexity doesn't sell. Or more precisely, complexity doesn't hold attention. And 3i/Atlas is beautifully, fascinatingly, frustratingly complex. There's no simple headline here, no clean narrative. You can't explain what makes this object special in a 6-word Twitter post or a 15-second TikTok. Try it yourself. How would you describe asymmetric cyanide and diatomic carbon emission patterns indicating heterogeneous surface composition with preferential volatile depletion in a way that makes someone stop scrolling? You can't. Not easily. Not in the time modern media gives you to capture someone's attention, which studies show is now less than 8 seconds. 8 seconds. That's less time than it takes to read this paragraph. Oumuamua had something 3i/Atlas. Doesn't a mystery simple enough for headlines? Is it aliens? 4 words. Everyone understands that question. It triggers something primal in us, the possibility of contact, of not being alone, of validation that we're part of something bigger. The speculation itself became the story, and speculation is infinitely easier to write about than spectroscopic analysis. But 3i/Atlas. It's doing something arguably more scientifically important. It's showing us the chemical fingerprints of planetary formation in another solar system. It's revealing how comets behave when they're not influenced by our sun's radiation over billions of years. It's offering a pristine sample of interstellar material that hasn't been contaminated by our cosmic neighbourhood. None of that fits in a headline. None of that makes your heart race. None of that makes you want to share it with your friends over coffee. And here's the really frustrating part: the timing couldn't be worse. 3i/Atlas reaches its closest point to our sun, what astronomers call perihelion, on December 19th, right in the heart of holiday season. Newsrooms run on skeleton crews between Thanksgiving and New Year's. Editors are on vacation. The journalists who might actually understand the significance of this discovery are spending time with their families. The few reporters still at their desks are covering holiday shopping trends, year-end retrospectives, and whatever political drama happens to be trending that day. Meanwhile, in observatories scattered across the globe, astronomers are watching something extraordinary unfold. Professional telescopes in Chile, Hawaii, and Spain are tracking this visitor's every move. Amateur astronomers, people like you, perhaps with backyard telescopes and a passion for the cosmos, are collecting data, sharing observations, building a picture of this object that grows more detailed every night. The European Space Agency has teams analysing its trajectory. NASA's infrared satellites are measuring its thermal signature. Researchers at universities from Tokyo to Cambridge are studying its spectral lines, trying to decode what this traveller can tell us about the space between stars. All of this is happening right now. Real science, real discovery, real implications for our understanding of how planetary systems form, how comets survive in interstellar space, how common these visitors might actually be. And yet, when you opened your newsfeed this morning, you saw none of it. The silence isn't just strange, it's revealing. It tells us something uncomfortable about how information flows in our modern world, about what we've decided matters and what we've agreed to ignore, about the difference between what's important and what's simply loud enough to hear. But silence isn't always empty. Sometimes, if you listen carefully enough, silence carries its own message. The absence of coverage for 3i/Atlas isn't random. It's the result of specific choices, specific systems, specific incentives that shape what you see and what remains invisible. So let's pull back the curtain. Let's examine exactly how modern media decides what becomes news and why a cosmic visitor racing through our solar system never stood a chance against the algorithm. There's a formula to what you see every day. You might not realise it, but every headline that crosses your screen, every notification that buzzes your phone, every story that trends on social media, they've all passed through an invisible filter, a calculation happening behind the scenes that decides what's newsworthy and what gets buried. Let me show you how it works. In journalism schools across America, they teach something called the news values, a checklist that helps editors decide what stories to cover. Timeliness, proximity, conflict, human interest, prominence, impact. It sounds objective. Doesn't it scientific even? But here's what they don't tell you in those classrooms in the age of digital media. There's a new value that trumps all the others. Engagement. Not importance, not accuracy, not societal value. Engagement. Clicks, shares, comments, watch time. Because in 2024, news isn't just information anymore, it's a product. And like any product, it lives or dies by one metric. Does it sell CNN, BBC, Fox News, MSNBC? They're not just news organisations anymore. They're content companies competing for your attention in an economy where attention is the most valuable currency on earth. Every second you spend watching their segment, reading their article, scrolling through their app, that's data they can sell to advertisers, that's revenue they can report to shareholders. So ask yourself this: which story do you think gets greenlit in the editorial meeting? Option A. Interstellar object displays asymmetric outgassing patterns. Complex, requires explanation, needs context. Maybe holds your attention for 90 seconds if the graphics are really good. Option B. Celebrity caught in shocking scandal, exclusive photos inside. Simple, emotional, instantly understandable. Keeps you clicking through a slideshow for 5 minutes, generating ad impressions with every click. The math isn't even close. There's actually a term for this in media studies: infotainment. The merger of information and entertainment. And it's not new, we've been heading this direction for decades. But social media accelerated it beyond anything we've seen before. Consider what happened just last month. Kim Kardashian posted a single Instagram photo, just one image, and it generated 47 million views in 3 hours. 3 hours. News articles about that photo. Over 200 published within 24 hours. Google searches spiked to 5 million. Twitter threads analysing her outfit, her caption, her location, thousands. Now compare that to the scientific paper announcing 3 I/Atlas's unusual chemical composition, published in the Astrophysical Journal in early November. Total downloads after 1 month, approximately 3,800. News articles covering the findings, 12. And most of those were in specialised publications like Sky and Telescope or Space. Outlets you have to actively seek out. One Instagram post versus groundbreaking scientific discovery. 47 million views versus 3,800 reads is not even a competition. But here's where it gets more revealing. The media industry knows exactly what you'll click on because they've been studying you, literally studying your behaviour for years. Every click you make, every article you abandon halfway through, every video you watch to completion, it's all tracked, analysed, fed into algorithms that predict what will hook you next. And those algorithms have learned something about human psychology that news executives now treat as gospel. We're drawn to stories we can understand instantly. Stories with clear villains and heroes. Stories that make us feel something strong: anger, fear, joy, outrage within seconds. Does 3I/Atlas make you feel something in 3 seconds? Be honest. When you first heard about it, did your heart race? Did you feel that surge of emotion that makes you want to tell someone? Share something? React immediately? Probably not. And that's not your fault. It's just how our brains are wired. There's a phrase you'll hear in newsrooms: if it bleeds, it leads. It's dark, but it's true. Studies conducted by the Pew Research Center found that negative news generates 63% more engagement than positive news. Conflict-driven stories get shared 74% more often than collaborative ones. Fear and outrage are rocket fuel for the attention economy, and space. Peaceful, distant, non-threatening space. It doesn't bleed, it doesn't create conflict, it doesn't make you angry at your political opponents or afraid for your safety. A comet passing through our solar system, no matter how scientifically significant, poses zero threat to anyone. It won't crash into Earth. It won't disrupt your life. It won't affect gas prices or your commute or your next paycheck. From a news value perspective, it's almost perfectly designed to be ignored. But wait, didn't Oumuamua get massive coverage? Didn't that interstellar visitor dominate headlines for weeks? Yes, and understanding why reveals everything about modern media. Oumuamua had something that 3i/Atlas doesn't: controversy. Specifically, alien controversy. When Professor Avi Loeb from Harvard suggested, even just as a possibility worth investigating, that Oumuamua's unusual acceleration might indicate artificial origins, the media machine ignited instantly. Is this our first contact with aliens? Harvard scientist says interstellar object could be alien probe. Are we being visited by extraterrestrial technology? Those headlines wrote themselves. They tapped into something primal, the question of whether we're alone in the universe. That's a story everyone understands. That's drama anyone can follow. You don't need a physics degree to wonder if aliens are real. You don't need to understand orbital mechanics to have an opinion about extraterrestrial life. The controversy around Oumuamua generated over 15,000 news articles. Loeb's speculation was debated on cable news. Late-night talk show hosts joked about it. It became part of the cultural conversation because it had a narrative hook simple enough for anyone to grab onto: 3i/Atlas. It's showing us legitimate chemical signatures from another star system. It's revealing how volatile compounds behave in interstellar space. It's offering clues about planetary formation processes we've only theorised about until now. But there's no alien angle, no controversy, no simple question that makes for a compelling headline. Just complex, beautiful, important science. And in the attention economy, complexity is a death sentence. The editorial calculation happens in seconds. Producer spots a story about 3i/Atlas, scans the summary, thinks, can I explain this in 90 seconds? Will viewers stay through the commercial break? Is there a viral moment here? The answer to all three questions is no. So the story gets passed over for something simpler, something more emotional, something that fits the formula they know works. This isn't a conspiracy. It's not malicious. It's just business. News organisations are struggling to survive in an ecosystem where attention is fractured across 1,000 platforms. They've learned what works, what fails, what pays the bills, and scientific discovery, unfortunately, rarely fits the model. But the truth is, the problem runs even deeper than simple economics, because even when journalists want to cover complex science, even when producers recognise the importance of a story like 3i/Atlas, there's another barrier waiting, one that stops these stories before they ever reach your screen. Let me take you back to October 19th, 2017. You're scrolling through your morning news, coffee in hand, barely awake when a headline stops you cold. Mysterious cigar-shaped object from another star system just passed through our solar system. Your brain snaps to attention. Wait, what? From another star system actually confirmed. This isn't science fiction, this is real. That moment of disbelief, that sudden jolt of cosmic wonder mixed with existential vertigo, that's exactly what millions of people felt when Oumuamua was announced. And that feeling, that's what made it newsworthy. But here's the part nobody talks about. Oumuamua almost didn't become the sensation it did, initially, when astronomer Robert Warwick at the University of Hawaii's Pan-STARRS telescope first spotted the object. It was catalogued quietly. Just another asteroid. Probably. Unusual trajectory. Sure. But space is full of unusual things. The initial press release from the International Astronomical Union was technical, measured, almost boring. Interstellar asteroid detected. Interstellar asteroid. Think about those words for a second. The first confirmed object from beyond our solar system ever observed by humans, and the official announcement treated it like a routine discovery. No exclamation points, no drama, just facts. The early news coverage reflected that tone. A few science outlets picked it up. Some astronomy blogs mentioned it, but mainstream media crickets. CNN didn't lead with it. The New York Times buried it on page A16. Most people had no idea it was even happening. Then Avi Loeb changed everything. Professor Abraham Avi Loeb, chair of Harvard's astronomy department, published a paper in November 2018, more than a year after Oumuamua's discovery, with a hypothesis that would ignite a media firestorm. The paper's title was carefully worded, scientifically cautious. Could solar radiation pressure explain Oumuamua's peculiar acceleration? But buried in that paper was a single sentence that would generate thousands of headlines. An artificial origin is worth considering. An artificial origin, as in built by someone, as in aliens. The media explosion was instant and overwhelming. Within 48 hours of that paper's publication, Oumuamua went from a footnote in Science News to the biggest story on the planet. Google Trends shows searches for Oumuamua spiking from near zero to over 10 million in a single week. News outlets that hadn't mentioned the object for a year suddenly couldn't stop talking about it. Harvard scientist interstellar object made by alien probe. Is Oumuamua an alien spacecraft expert says it's possible? First contact mysterious space object could be technology from another civilization. Notice what happened there? The story transformed from weird space rock into possible alien encounter. Same objects, same data, but completely different narrative. And that narrative, that possibility of contact with extraterrestrial intelligence, fit perfectly into the news formula we talked about earlier. It had everything. Mystery. Where did it come from? Drama, are we alone? Conflict scientists debating whether Loeb's hypothesis was brilliant or reckless. Human interest. What would it mean for humanity if we'd actually been visited? You could explain it to anyone in one sentence. A Harvard scientist thinks that weird object that flew through our solar system might be an alien probe. Your grandmother would understand that. Your 7-year-old would find it fascinating. It transcended expertise, education, background. Everyone could have an opinion. And here's the crucial part: you didn't need to understand the actual science to engage with the story. Most news articles about Oumuamua never explained what non-gravitational acceleration meant. They didn't dive into solar radiation pressure or outgassing dynamics or why Oumuamua's movement didn't match standard comet behaviour. They didn't need to. The alien angle was enough. The controversy itself became the content. Scientists who disagreed with Loeb got quoted. Loeb defended his position. Other researchers proposed alternative explanations. Debates erupted on Twitter. Podcasts dedicated entire episodes to the discussion. Documentary filmmakers started developing projects. By the time the frenzy peaked in early 2019, Oumuamua had generated over 15,000 news articles, appeared in hundreds of broadcast news segments, and became a cultural reference point. Late-night comedians joked about it. It showed up in memes. People who'd never looked through a telescope were suddenly arguing about interstellar objects at dinner parties. All because of one word: artificial. Now fast forward to 2I/Borisov, discovered in August 2019, less than 2 years after Oumuamua. This was the second interstellar visitor ever confirmed, second ever in human history. Think about how significant that is. We'd gone from "did that really just happen" to "it's happening again in under 24 months. The scientific community was thrilled. Astronomers worldwide pointed their telescopes at 2I/Borisov, gathering unprecedented data about an object from beyond our solar system. Unlike Oumuamua, which was discovered after its closest approach to the Sun, Borisov was detected while inbound. Scientists had time to prepare, to coordinate observations, to study it properly. The data was incredible. Spectroscopic analysis revealed chemical compositions never before observed in solar system objects. It showed cyanide gas emissions, water vapour signatures, evidence of carbon monoxide outgassing. It was a chemistry textbook from another star system, racing through our cosmic backyard at 175,000 kilometers per hour. How much news coverage did it get? Barely a whisper. Total news articles about 2I/Borisov, approximately 800. That's less than 6% of Oumuamua's coverage. Google searches peaked at around 500,000, 20 times less interest. Social media engagement, almost non-existent compared to its predecessor. Why? because 2I/Borisov looked and behaved exactly like a comet. Fuzzy coma, tail, outgassing that explained its motion. Everything about it screamed natural object. It was fascinating scientifically, but it wasn't mysterious. There was no alien angle, no controversy, no debate that could be packaged into a headline simple enough for mass consumption. The lesson was clear: mainstream media doesn't care about science. It cares about stories, and sometimes the truth is too straightforward to be a good story. Which brings us to the uncomfortable reality facing 3I/Atlas right now. This object is doing something arguably more interesting than Oumuamua ever did. Its chemical emissions are genuinely strange multicoloured jets, asymmetric activity, unusual ratios of molecules that suggest a composition unlike anything we've seen. But there's no credible scientist suggesting it's artificial. There's no controversy hook. There's no simple narrative. It's just weird, scientifically fascinating weird, complex weird. Weird that requires explanation and context and patience to understand. And in modern media, that kind of weird gets ignored. But the silence around 3I/Atlas isn't just about lacking an alien angle. There's another barrier, one even more fundamental, that stops complex science from reaching mainstream audiences. And it has everything to do with how we communicate scientific discoveries in an age where attention spans are measured in seconds. Imagine you're a science journalist sitting in a newsroom in Manhattan. It's 9 a.m. on a Tuesday, and your editor just forwarded you a press release from the European Space Agency. The subject line reads, "New observations of interstellar object 3I/Atlas reveal anomalous CN/C2 emission ratios." You open it, start reading. Spectroscopic analysis conducted using the 8.2-metre Very Large Telescope at Paranal Observatory indicates statistically significant deviations in the cyanide radical to decarbon molecule production rates compared to established models of cometary volatile sublimation under varying heliocentric distances. Your eyes glaze over. You read it again. Then a third time. You still don't fully understand what it's saying. And here's the uncomfortable truth: you have exactly 45 minutes until the morning editorial meeting where you'll need to pitch this story to an editor who definitely won't understand it, who will then need to explain it to a producer who has even less science background, who will ultimately present it to viewers who just want to know, why should I care? How do you translate that press release into a headline? This is the complexity barrier. And it kills science stories before they ever reach the public. Let's contrast this with a story that did break through. In July 2020, scientists announced they'd found evidence of liquid water lakes beneath Mars's south polar ice cap. The discovery was published in Nature Astronomy, one of the most prestigious journals in the field. The actual paper was dense, technical, filled with radar data interpretation and subsurface analysis. But the headline everyone ran with: water found on Mars. 3 words, that's it. 3 words that everyone on Earth can understand instantly. You don't need a physics degree. You don't need to know what ground-penetrating radar is. You don't need to understand ice-penetrating electromagnetic wavelengths. Water, Mars, found. Those 3 words tell you everything you need to know to decide if you're interested. That story generated over 8000 news articles in the first week. It trended on Twitter for 3 days. Late-night hosts joked about it. It became a cultural moment. Now try to do the same thing with 3I/Atlas. Interstellar object shows weird chemistry. Okay, but what does that mean? Weird how? Why does it matter? You've used 8 words and still haven't communicated anything concrete enough for someone to care about. Comet from another star has strange gas emissions. Better, maybe. But now you're competing with 1,000 other space stories that sound equally vague. What makes this one special? Here's where it gets really challenging. The things that make 3I/Atlas scientifically fascinating are precisely the things that make it impossible to explain quickly. Take the asymmetric outgassing. For instance, what astronomers are observing is this: when 3I/Atlas releases gas and dust, which all comets do as they get closer to the sun, it's not doing it evenly. The jets of material are shooting out more strongly from one side than the other. and the ratio of different molecules in those jets doesn't match what we see in solar system comets. Why is that important? Because it suggests the surface composition is different from place to place. Some areas might be rich in water ice, others in carbon dioxide, others in more exotic frozen compounds, and that patchwork composition could tell us about the conditions in whatever stellar system 3I/Atlas formed in billions of years ago. It's like finding a message in a bottle that's been floating across an ocean for centuries, but the message is written in a language you're still learning to read. Every molecule, every emission line, every variation in brightness is a word in that alien vocabulary. Can you fit that into a tweet? Can you explain it in the 8 seconds you have to grab someone's attention? The Mars water story worked because water is something everyone understands. We drink it. We swim in it. We need it to live. When you say water on Mars, people immediately make connections. Could there be life? Could we live there someday? The science translates instantly into implications everyone can grasp. But asymmetric CN/C2 emission ratios, that's not something anyone has personal experience with. Cyanide molecules aren't part of everyday life. Dicarbon compounds aren't something you encounter at the grocery store. There's no immediate bridge between the scientific observation and human experience. And here's the paradox. The more precisely scientists communicate their findings, the less accessible those findings become to general audiences. Look at how the discovery of 3I/Atlas was announced. The initial paper, submitted to the astrophysical journal Letters in September, used language like this. We present multi-wavelength photometric and spectroscopic observations of the third known interstellar object, exhibiting hyperbolic orbital elements and non-gravitational acceleration components consistent with volatile-driven outgassing. That sentence is accurate. It's precise. It communicates exactly what scientists observed, and it's completely incomprehensible to 99% of the population. Compare that to how NASA announced the Mars helicopter's first flight in April 2021. NASA's Ingenuity Mars helicopter became the first aircraft in history to make a powered, controlled flight on another planet. See the difference? One sentence tells you exactly what happened and why it matters. No jargon, no technical terminology, just a clear statement that creates an image in your mind, a helicopter, flying on another planet. You can picture it immediately. The challenge with 3I/Atlas is that there's no simple visual. There's no single moment that captures the significance. It's not a rover landing. It's not a telescope image. It's data streams of numbers and wavelengths and spectra that only make sense when you understand what you're looking at. Even when astronomers try to simplify it, they run into problems. You might say this comet is chemically different from our solar system's comets. Okay, but then the immediate questions are different. How? Why does that matter? What does it mean? And to answer those questions properly, you need to explain stellar nuclear synthesis, planetary formation theory, volatile compound distribution in protoplanetary disks. You need to teach someone astronomy. In a news article, in 3 minutes, most journalists don't have the background to do that translation work. According to a 2019 survey by the Council for the Advancement of Science Writing, only 12% of newsroom journalists covering science stories have any formal science education beyond high school. They're talented writers, skilled reporters, but they're being asked to explain quantum mechanics to an audience while barely understanding it themselves. So what happens? They either don't cover the story at all, or they simplify it so much that the actual science disappears, leaving only vague statements like, scientists are excited about a new discovery in space. And that vagueness, it can't compete with the clarity of celebrity gossip, political drama, or sports highlights. But the complexity barrier isn't the only obstacle 3I/Atlas faces. There's something even more fundamental working against it, something that has everything to do with when this discovery happened. December 19th, 2024. Mark that date in your mind, because on that day, something extraordinary happens. 3I/Atlas reaches perihelion, its closest point to our Sun, passing within roughly 140 million kilometres of the star that's been pulling it inward for months. For this interstellar traveller, it's the climax of a journey that began in another solar system, possibly millions of years ago. For the news media, it's the worst possible timing imaginable. Let me paint you a picture of what a typical newsroom looks like in mid-December. Half the staff is on vacation days taken before they expire at year's end. The assignment desk is running on a skeleton crew, senior editors who might actually recognise the significance of an interstellar object reaching perihelion. They're spending time with family, finally taking that break they postponed all year. The journalists still at their desks are grinding through the annual ritual year-end retrospectives, holiday shopping trends, weather warnings for travellers, feel-good stories about community toy drives. Nothing wrong with any of that, these are stories that matter to people's daily lives. But they're also stories that follow predictable templates, require minimal research, and can be produced quickly. Now imagine pitching a complex astronomy story in that environment. You're competing against top 10 moments of 2024 inches listicles that practically write themselves, against holiday travel chaos stories that update themselves every few hours, against the final political dramas of the year as Congress rushes to pass legislation before the holiday recess. Every editor's looking for content that's fast, simple, and relevant to viewers planning their holiday celebrations. Hey, there's this interstellar comet reaching its closest point to the sun on the 19th. Just doesn't fit the December news agenda, but the timing problem runs deeper than just holiday scheduling. There's something else working against 3i/Atlas. Something built into the very structure of how scientific discoveries become public knowledge. Here's how the process typically works. An astronomer makes an observation. They analyse the data. They write a paper describing their findings. That paper gets submitted to a peer-reviewed journal, something like Nature, Science, the Astrophysical Journal. Then it sits, waits, gets assigned to reviewers who are themselves busy scientists with their own research projects. Those reviewers read it carefully, check the math, scrutinise the methodology, sometimes request additional analysis or clarification. The whole process, typically 6 to 12 months, sometimes longer. During that waiting period, the paper exists in what's called preprint form. It's available online. Other scientists can read it and discuss it, but it hasn't received that official stamp of approval from peer review. And here's the critical part: mainstream media won't touch it. Why? Because they've been burned before. Remember the faster-than-light neutrino incident from 2011? Scientists at CERN announced they'd detected neutrinos travelling faster than light speed, potentially overturning Einstein's theory of relativity. Some news outlets ran with it immediately. Big headlines, massive implications. Except it turned out to be a measurement error. A loose fibre optic cable was causing timing discrepancies in the detection equipment. When the mistake was discovered months later, those news organisations looked foolish for having reported unverified results. Since then, major outlets have adopted strict policies. They only report on peer-reviewed, published research. It's a reasonable standard. Peer review exists for good reasons, but it creates a timing problem. By the time a scientific paper about 3i/Atlas completes the peer review process and gets officially published, the object might have already passed perihelion and be heading back out toward interstellar space. The moment of maximum scientific interest, when the comet is closest to the sun, most active, easiest to observe, happens before the media is willing to cover it. Think about how absurd that is. The discovery is happening in real time. Astronomers are observing it right now, sharing preliminary findings, discussing unusual features in professional forums. But mainstream news won't report it until someone in a peer review committee signs off, which could be months from now. It's like refusing to report on a hurricane until the meteorological data has been peer-reviewed and published in an academic journal. By that point, the hurricane has already made landfall, caused its damage, and moved on. Compare this to discoveries that had better timing. When the James Webb Space Telescope captured its first images in July 2022, NASA didn't wait for peer review. They held a press conference. released the images to the public immediately. The media coverage was instant and enormous. Those deep field images were everywhere, from the front page of the New York Times to Instagram feeds of people who'd never looked at an astronomy photo before. Why could they do that? Because the images spoke for themselves. You didn't need peer review to confirm that yes, those are galaxies from the early universe. And yes, they're stunningly clear. The visual evidence was undeniable, but spectroscopic data showing unusual chemical ratios in a distant comet that requires interpretation. Context, expert analysis. You can't just look at it and know what it means. So scientists follow protocol, submit to journals, wait for peer review, and while they wait, the news cycle moves on. Even when astronomers try to work around this by issuing astronomers' telegrams rapid, preliminary announcements of significant observations, most science journalists don't know these exist. They're not press releases. They're communications between professionals, written in technical language, distributed through specialized channels. 3I/8LAS was announced via astronomers' telegram #16011 in early September. It described the discovery, provided orbital parameters, called for additional observations from the global astronomy community. Within days, dozens of telescopes worldwide were tracking it. Data started accumulating. Exciting patterns emerged. How many mainstream news articles resulted from that announcement? Essentially zero. The few outlets that did cover it waited weeks or months, until enough data had been gathered and analysed that someone felt comfortable making more definitive statements. By then, the initial excitement had faded. The story felt old, even though the object was still approaching, still active, still revealing new details. And now, here we are. Approaching December 19th, the date when 3I/8LAS makes its closest pass by our Sun, when its activity should peak, when observations will be most valuable. But newsrooms are already in holiday mode. The few science journalists still working are wrapping up their year-end pieces. Assignment editors are focused on seasonal content. The perfect storm of bad timing, a complex discovery requiring expert interpretation, reaching its scientific climax during the year's slowest news period, following a publication timeline that lags months behind the actual observations. But even if the timing were perfect, even if this were happening in April when newsrooms are fully staffed and looking for fresh stories, there's another layer to this silence. One that has everything to do with how the scientific community itself chooses to communicate or not communicate with the public. There's a culture of silence in professional astronomy that most people never see. It's not conspiracy or secrecy, it's something more subtle. Something born from decades of hard lessons about what happens when scientists speak too soon, claim too much, or let excitement override caution. Let me tell you about Tabby's star. In September 2015, astronomer Tabitha Boyajian and her team published findings about KIC 8462852, a star 1/400 light-years away, exhibiting the strangest light patterns ever observed. Something was blocking up to 22% of the star's light at irregular intervals. Nothing in astronomy could explain it. Not planets, they'd block maybe 1% at most. Not dust clouds, the pattern was too structured. Not stellar activity, the dimming events were too dramatic. The scientific paper was cautious, methodical, exploring multiple natural explanations. But one line captured everyone's imagination. The patterns were consistent with what you might expect from massive artificial structures orbiting the star. The media went absolutely wild. Alien megastructure around distant star. Have we finally found evidence of advanced civilization? Scientists baffled by possible Dyson sphere. For weeks, Tabby's star was everywhere. Press conferences, TV interviews, social media debates. The public was captivated. Here, finally, was potential evidence of intelligent alien life, the holy grail of astronomy. Then came the follow-up observations. More data, better analysis. By 2018, the mystery was solved. Dust. Specifically, an irregular cloud of dust particles of varying sizes passing in front of the star. Natural. Mundane. No aliens required. the scientific community had done exactly what it was supposed to do: observe, hypothesize, test, refine. But the public felt betrayed. Scientists got it wrong. Another false alarm. Why should we believe them next time? And astronomers learned a painful lesson: public excitement can turn into public skepticism very quickly. Since then, major observatories have become incredibly careful about what they announce and how they announce it. The European Space Agency, NASA, the European Southern Observatory. These institutions now follow strict communication protocols. Nothing gets released to the public unless it's been verified multiple times, analysed thoroughly, and deemed absolutely certain, which brings us back to 3I/Atlas. Right now, observatories across the world are tracking this object: the Very Large Telescope in Chile, the Gemini Observatory in Hawaii, the Gran Telescopio Canarias in Spain. They're collecting spectroscopic data measuring brightness variations, analysing the composition of outgassing materials. The data is fascinating, genuinely strange in ways that excite professional astronomers. But you won't see ESA issuing breathless press releases about it. You won't see NASA holding press conferences, because the data, while intriguing, isn't yet conclusive enough to explain with certainty why 3I/Atlas behaves the way it does. And institutional science has learned that "we don't know yet" doesn't play well in modern media. Think about it from their perspective. What happens if ESA issues a press release saying interstellar object exhibits unexplained chemical anomalies? The media immediately starts speculating. Are those anomalies evidence of something artificial? Could this be significant? What aren't scientists telling us? Then, 3 months later, after more observations and analysis, it turns out there's a perfectly natural explanation. Maybe unusual composition from forming in a different stellar environment. Maybe unexpected interaction with interstellar radiation during its long journey. The science has progressed exactly as it should. But the headlines become "false alarm, mysterious interstellar object, just a normal comet after all." Each cycle of hype and disappointment erodes public trust a little more. So institutions stay quiet until they're absolutely certain. There's another factor at play here too: funding politics. NASA's annual budget battles with Congress are brutal. Every program, every mission, every telescope competes for limited resources, and public perception matters enormously in those fights. When the James Webb Space Telescope launched successfully in December 2021 and started returning stunning images, public enthusiasm translated directly into political support. Congressional representatives heard from constituents excited about space exploration. That enthusiasm made it easier to justify the next major mission, the next budget allocation. But controversy, uncertainty, those create political vulnerability. If NASA promotes a discovery that later proves incorrect or overhyped, critics use that to question whether the agency deserves its funding. They can't even get their facts straight. Why should we give them billions of dollars? So NASA, ESA, and other major institutions have adopted a strategy of conservative communication. Only announce what you're certain about. Only promote findings that have been exhaustively verified. Avoid speculation. Stick to facts. It's a rational approach for institutional survival. But it means discoveries like 3I/Atlas complex, still being analysed, genuinely uncertain in their implications, get minimal official attention. Compare this to how private or independent astronomers operate. People not bound by institutional protocols, not worried about how their statements might affect billion-dollar budget negotiations. The amateur astronomer who first detected unusual activity in 3I/Atlas posted his findings online within hours. No committee approval needed, no press office review, no institutional reputation to protect, just raw enthusiasm for what he was seeing and a desire to share it with others who'd appreciate it. Professional astronomers see those posts, they read the forums, follow the discussions, contribute their own observations. There's a whole parallel universe of scientific communication happening online in astronomers' Telegram posts, on specialised forums, in Twitter threads where researchers share preliminary findings with colleagues. But it's invisible to mainstream media because it lacks official authority. A press release from NASA carries weight. A forum post from an astronomer at a university, no matter how expert they are, doesn't get quoted by the Associated Press. And here's the irony. Some of the most interesting discussions about 3i/Atlas are happening right now in these unofficial channels. Researchers debating what the unusual chemical ratios might mean. Theorists proposing models to explain the asymmetric outgassing. Observers sharing new data that refines our understanding of the object's behaviour. It's real science, happening in real time. But because it lacks the stamp of institutional approval, it might as well not exist from a media perspective. You might wonder, couldn't individual scientists just speak out on their own, share their excitement about 3i/Atlas directly with the public? Some do, but they face pressure from their institutions to be cautious. Too much self-promotion can be seen as unprofessional. Making claims that later prove incorrect can damage your reputation. In a field where your credibility is everything, where it determines whether you get telescope time, whether your papers get published, whether you receive grants, most astronomers choose caution. Better to say nothing than to say something that might later need correction. Better to wait for certainty than to share excitement about possibilities. And so the silence deepens, not through any single decision, but through 1,000 small choices made by institutions and individuals trying to protect themselves from the consequences of being wrong in public. But while official channels stay quiet, something else is happening. Something that's beginning to change how science reaches audiences. Something that doesn't require institutional approval or fear the consequences of uncertainty. Open TikTok right now, search for space. What do you find? Flat Earth videos with millions of views? Conspiracy theories about NASA hiding the truth, with comment sections full of passionate debate. CGI renderings of black holes swallowing planets, dramatic, terrifying, completely fictional, racking up view counts in the tens of millions. A 19-year-old influencer explaining why we've never been to the moon to an audience of 4.2 million followers. Now search for 3i/Atlas. Go ahead, try it. You'll find maybe a dozen videos total. Most have fewer than 500 views. The ones with actual scientific content created by astronomers trying to share real observations average about 90 seconds of watch time before viewers click away. Comments maybe 5 or 6, usually from other astronomy enthusiasts. This is the social media paradox. The platforms that should democratize information, that should make scientific discovery accessible to everyone, have instead become amplifiers for whatever holds attention longest, regardless of accuracy. And the algorithm doesn't care about truth. It cares about engagement. Let me show you how this works. YouTube's recommendation algorithm, the system that decides what video to suggest to you next, optimizes for one primary metric: watch time. Not educational value, not accuracy, not scientific rigor. Just how long did you watch before clicking away? A flat Earth video that keeps viewers engaged for an average of 8 minutes will get promoted over an astrophysics lecture that loses half its audience in the first 90 seconds. Even if the lecture is accurate and the flat Earth video is demonstrably false, the algorithm can't evaluate truth, it can only measure attention. And here's what research shows: conspiracy theories and pseudoscience consistently outperform real science in holding viewer attention. A 2022 study from MIT's Media Lab analysed over 26,000 science-related videos on YouTube. They found that videos containing scientific misinformation had an average watch time 47% higher than factual content. Why? Because misinformation tends to be simpler, more emotional, more dramatic. It presents clear villains and heroes. It validates existing beliefs rather than challenging them. Real science is harder. It requires you to sit with uncertainty, to understand nuance, to follow complex arguments that might take several minutes to fully develop. It asks you to change your mind based on evidence, which is psychologically uncomfortable. So when you're scrolling at 11 p.m, tired from a long day, looking for something to watch before bed, are you going to click on "Shocking NASA hides evidence of alien megastructure"? Or "Spectroscopic analysis of interstellar object 3i/Atlas reveals compositional anomalies"? Be honest with yourself. Which one sounds more immediately interesting? The first title promises drama, revelation, emotion. The second promises work, mental effort, concentration. Even if you're intellectually curious about astronomy, that second video is asking a lot from you in that moment. And the platforms know this. TikTok's algorithm, famously addictive, optimizes even more aggressively than YouTube. Videos need to hook you in the first 3 seconds or they're buried. That's why you see quick cuts, flashy graphics, loud music, rapid-fire information. It's all designed to grab your attention before your thumb swipes to the next video. Can you explain what makes 3I/Atlas scientifically significant in 3 seconds? Can you make asymmetric molecular emissions visually compelling enough to stop someone mid-scroll? The few astronomy content creators who've tried to make 3I/Atlas content for TikTok have struggled with exactly this problem. One creator, an astrophysics PhD student with 380,000 followers, posted a 60-second explanation of the discovery. She used dynamic graphics, upbeat music, fast pacing, all the tricks that usually work. The video got 12,000 views. Sounds decent. Right, except her average video gets 400,000 views. Her most popular post, a joke about Mercury being the spicy planet because it's close to the Sun, has 8.2 million views. Think about that ratio. A scientifically meaningless joke, 8.2 million. A real interstellar discovery, 12,000. The algorithm rewarded simplicity and humour over substance and accuracy by a factor of nearly 700 to 1. Instagram isn't much better. Beautiful astrophotography does well. They're stunning images of nebulae, galaxies, the Milky Way arching over landscapes, but 3I/Atlas, it's too faint to photograph with consumer equipment. The scientific observations are spectroscopic data, essentially graphs showing the intensity of different wavelengths of light. Those graphs are meaningful to astronomers, but they're not Instagram-worthy. They don't pop on a small screen. They don't make people stop scrolling. Twitter, now X, presents a different challenge. Character limits force, extreme simplification. A recent study from the University of Warwick found that science tweets with the highest engagement rates contained, on average, 3.7 factual errors per tweet. Why? Because accurate science requires caveats, context, qualifications, all the things that make a tweet longer and less shareable. A perfectly accurate tweet about 3I/Atlas might read, "New observations suggest compositional heterogeneity in interstellar object 3I/Atlas," though additional data needed to confirm interpretation. Preliminary spectroscopic analysis indicates CN/C2 ratio variations consistent with differential volatile depletion, but alternative explanations possible. That tweet would get maybe 15 likes and 2 retweets, probably from other planetary scientists. A less accurate but more engaging tweet. Breaking alien comet from another solar system shows chemistry never seen before, scientists baffled. That tweet goes viral. It gets quoted, screenshot, shared across platforms. It generates debate, speculation, excitement. It's also misleading. The chemistry isn't from aliens. Scientists aren't baffled. And several aspects have been seen before, just not in this specific combination. But the algorithm rewards the second tweet, amplifies it, suggests it to more users, creates a feedback loop where sensationalism spreads faster than accuracy. Here's the really troubling part. This dynamic actively discourages scientists from engaging on social media. Why would you spend time crafting accurate, nuanced posts that get ignored when you see misinformation getting millions of views? It's demoralizing. Many astronomers have simply stopped trying to compete in that space. They retreat to professional journals, academic conferences, specialized forums where accuracy is valued over virality. And in doing so, they cede the social media landscape to whoever's willing to prioritize engagement over truth. There was a brief moment, maybe a decade ago, when it seemed like social media might transform science communication. Scientists could speak directly to the public, bypass traditional media gatekeepers, share discoveries in real time. Some still do. Neil deGrasse Tyson has 14 million Twitter followers. Brian Cox has 3 million. But look closely at what content performs best, even for them. It's the simplified, the entertaining, the accessible. The deep dives into complex topics, those get a fraction of the engagement. And so, 3i/Attilas remains invisible on platforms where billions of people spend hours every day. Not because it's uninteresting, not because people wouldn't find it fascinating if they knew about it, but because the systems designed to surface content have decided it doesn't fit the pattern of what keeps eyes on screens. Yet there's another layer to this silence, one that might seem paradoxical given everything we've discussed. Because while 3i/Attilas struggles for attention, the funding that makes its discovery possible depends on that very attention. And that creates a vicious cycle. Follow the money, it's advice that works for understanding almost any system. And astronomy is no exception. Here's how it flows. A discovery gets made, media covers it, public gets excited. That excitement translates into political will. Politicians respond by allocating funding. That funding enables more discoveries, and the cycle continues or breaks. Right now, NASA's Planetary Science Division has an annual budget of approximately $3.2 billion. Sounds like a lot, doesn't it? But consider what that money needs to accomplish missions to Mars, Venus, Jupiter's moons, Saturn's rings, asteroid flybys, telescope operations, data analysis, research grants to universities, technology development for future missions. Every single program fights for its slice of that budget. And the programs that survive, they're almost always the ones the public knows about and cares about. Let me show you a concrete example. The Mars Perseverance rover, you've heard of it? Right. It's been on Mars since February 2021, searching for signs of ancient life. Collecting samples, flying that little helicopter named Ingenuity. NASA's website shows the mission has received over $2.7 billion in funding from initial development through current operations. Why did Perseverance get funded? Because Mars excites people. When NASA announced the mission in 2012, media coverage was extensive. The public responded enthusiastically. A nationwide naming contest for the rover drew over 28,000 entries from students. By the time Perseverance launched, millions of people were invested in its success emotionally, intellectually, culturally. When NASA goes before Congress to request continued funding for Mars exploration, representatives hear from constituents, emails from science teachers wanting to use Mars discoveries in their classrooms, letters from students inspired to study planetary science, tweets from taxpayers saying, "This is what I want my tax dollars supporting." That groundswell of public support translates directly into political support. And political support translates into funding. Now consider programs that don't have public visibility. The Interstellar Object Studies Initiative, a proposed program to develop rapid response capabilities for detecting and studying objects like 3i/Attilas, requested $45 million in initial funding in the 2024 budget cycle. It was cut entirely. Why? Because when congressional staffers researched whether constituents cared about interstellar objects, they found almost no public engagement. No emails, no letters, no social media campaigns. The general public didn't know these objects existed, didn't understand their scientific value, didn't care whether we studied them or not. From a political perspective, funding interstellar object research meant taking money away from programs people did care about Mars. The Moon, asteroids that might hit Earth. Easy decision, cut it. Do you see the vicious cycle? No media coverage means no public awareness. No public awareness means no political pressure. No political pressure means no funding. No funding means fewer discoveries and less capability to study objects like 3i/Attilas, which means less media coverage. And around it goes. Compare that to how the James Webb Space Telescope became reality. The initial concept emerged in 1996. Early media coverage was sparse in another space telescope. So what, but as the mission developed, NASA's public outreach team worked hard to build anticipation, artist renderings of what Webb might see, explanations of how it would peer back to the universe's first galaxies, regular updates on construction milestones. By the time Web launched in December 2021, it had its own hashtag trending on Twitter. Millions of people watched the launch livestream. When those first images came back in July 2022, they were everywhere, not just in science publications, but on Instagram, in mainstream news, on late-night talk shows. That visibility protected the mission through years of budget overruns and delays. Webb's final cost reached $10 billion, more than 3 times the original estimate. In most circumstances, a project that far over budget gets cancelled. But Webb survived because the public cared. People wanted those images. They wanted to see the universe's first light. They made their desires known to their representatives. Congressional appropriators couldn't kill a program that had become a cultural touchstone. The political cost would be too high. This creates a troubling dynamic where scientific importance becomes secondary to public relations. A mission's survival depends not on what it might discover, but on whether those discoveries can be packaged into media-friendly stories. The Europa Clipper mission launching to Jupiter's potentially habitable moon has strong public support because the narrative is simple. Looking for life in an alien ocean. The scientific reality is far more complex and uncertain, but that hook is enough. Budget $4.25 billion, fully funded. Meanwhile, the proposed interstellar probe, a spacecraft designed to leave our solar system and study the space between stars, has languished in planning stages for over a decade. Why? Because studying the space between stars doesn't capture imagination the same way searching for alien life does. The science might be equally important, but the story is harder to tell. And here's where it gets personal. Think about astronomers studying 3I/Atlas right now. They're using telescope time that's incredibly precious. Observatories like the Very Large Telescope allocate time in competitive proposals where sometimes only 10 to 20% of requests get approved. Those astronomers had to justify why studying this interstellar visitor deserved telescope hours that could have gone to dozens of other projects. They made scientific arguments, unique opportunity to study pristine material from another star system, rare chance to observe interstellar chemistry, crucial data for understanding planetary formation beyond our sun. Their proposals won on scientific merit. But now they're gathering all this fascinating data, making discoveries that could reshape our understanding of how planetary systems form and evolve, and almost nobody outside their immediate field knows or cares. When it comes time to renew those telescope allocations, to request funding for continued observations, to justify why interstellar object research deserves resources, they'll face tough questions. What's the broader impact? Who benefits from this research? Why should taxpayers fund it? And the honest answer is this research expands human knowledge about the universe. It helps us understand our cosmic context. It reveals processes we can't study any other way. But that's not an answer that wins budget battles. What wins budget battles is the public is excited about this. Media is covering it. People are calling their representatives asking for more. The irony is crushing. Some of the most important scientific work being done right now, observations that future astronomers will build on for decades, is being conducted with minimal funding, minimal support, and zero public awareness. While programs with better publicity, better narratives, better media strategies receive resources far beyond what scientific merit alone would justify. I'm not saying those well-funded programs aren't valuable, many absolutely are, but the funding gap reveals uncomfortable truths about how we prioritize knowledge-seeking as a society. What we pay attention to shapes what we learn, and what we learn shapes what becomes possible. Yet even as institutional funding follows public attention, something remarkable has been happening outside those traditional structures. A different kind of astronomy, driven by different motivations, operating by different rules. On the night of September 2nd, 2024, a man named Peter Veras was sitting in his backyard in Slovakia, not at a professional observatory, not using a multi-million-dollar telescope. Just a 14-inch reflector telescope that cost him about $500, set up next to his garage. Pointed at a patch of sky most people wouldn't give a second glance. He was running software he'd written himself, code designed to detect objects moving against the background stars. Automated, patient, scanning the same regions night after night, looking for anything that didn't belong. At 11:47 p.m. local time, his computer flagged something unusual, an object moving fast, very fast, wrong direction for an asteroid. Trajectory didn't match anything in the solar system database. Peter spent the next 3 hours confirming what he was seeing, triple-checked his calculations, analysed the motion, ran the orbital dynamics through multiple programs. By 2:30 a.m, he was certain this was something from beyond our solar system. He was the first human being to detect 3 I/Atlas. Not NASA, not ESA, not the Hubble Space Telescope or the James Webb or any of the billion-dollar facilities we've talked about. A retired engineer in Slovakia with consumer-grade equipment and a passion for the night sky. And he's not alone. Right now, as you're hearing this, there's a quiet revolution happening in astronomy. Thousands of people around the world, teachers, engineers, retirees, students are contributing to our understanding of the universe using equipment you could buy with a decent tax refund. The Amateur Telescope Network, loose collaboration of backyard astronomers across 47 countries, has made over 12,000 observations of 3 I/Atlas since its discovery. They're tracking its brightness variations, measuring its position with precision that rivals professional facilities. Some are even attempting spectroscopy, breaking down its light into component wavelengths to analyse its composition. Their data gets uploaded to shared databases. Professional astronomers use it. Papers get published incorporating observations from people who've never set foot in an observatory. The line between amateur and professional is blurring faster than anyone expected. How is this possible? Technology has democratized the cosmos. A telescope that would have cost $50,000 in 1990 now costs $3,000. Camera sensors sensitive enough to detect faint objects. You can get them for $800. Software to process images and extract scientific data, free, open source, developed by communities of enthusiasts who share knowledge freely. Want to track an interstellar object yourself? Here's what you need: a decent telescope with computerized tracking, a CCD camera, software like Astrometrica or AstroImage-J, and access to online databases that tell you where to point. Total cost may be $5,000 to $8,000, less than a used car. And here's what's remarkable: you don't need a PhD to contribute meaningful observations. You need patience, clear skies, and willingness to learn. The Amateur Astronomer Association of New York offers free training courses. Online forums walk newcomers through every step. YouTube tutorials show you exactly how to set up your equipment. One contributor to the 3 I/Atlas observation campaign is Sarah Chen, a high school physics teacher in Vancouver. She bought her telescope 3 years ago, initially just to show students the rings of Saturn. Now she's part of an international team tracking interstellar visitors. Her observations from October 15th helped confirm unusual brightness variations that suggest the object is tumbling as it moves. Her data appears in the same databases professional astronomers consult. Her name will likely appear in the acknowledgements of peer-reviewed papers, or from her backyard. This is what the democratization of astronomy looks like. But it goes beyond just collecting observations. Citizen science platforms have transformed how discoveries happen. Zooniverse, a web portal hosting dozens of science projects, has over 2.5 million registered volunteers who help analyze data that would take professional scientists decades to process alone. The Planet Hunters project, hosted on Zooniverse, has found over 100 confirmed exoplanets. Not found by professionals, found by volunteers examining light curves from NASA's TESS satellite. People with no formal astronomy training, learning to recognize the subtle dips in starlight that indicate a planet passing in front of its star. One of those volunteers, a mechanic from Tennessee named David Thompson, discovered a planet orbiting a star 350 light-years away. He did it during his lunch breaks, examining data on his phone. When asked how it felt to discover a world, he said, "It's surreal. I fix cars. but I found a planet. That's going to exist for billions of years. And I'm the first human who knew it was there. That's the power shift happening right now. Knowledge isn't locked behind institutional walls anymore. The tools exist. The data is accessible. All you need is curiosity and commitment. Reddit's astronomy community's A Space has 25 million members. Where astronomy has 1.8 million are discussing 3i/Atlas in real time. Sharing observations, debating interpretations. Sometimes their discussions happen days before professional papers addressing the same questions get published. When unusual jet activity was observed in 3i/Atlas in early November, amateur astronomers were posting enhanced images and preliminary analyses online within hours. Professional astronomers saw those posts, adjusted their observing plans, coordinated follow-up observations. The traditional hierarchy of knowledge professionals discover, then eventually tell the public has inverted. Now sometimes the public discovers first, or at least notices first, and professionals respond. This creates interesting tensions. Some traditional astronomers resent the intrusion. They've spent decades earning expertise, and here come hobbyists with no formal credentials making observations, offering interpretations, sometimes even publishing in peer-reviewed journals. But most professionals recognize what's happening. The collective processing power of thousands of amateur astronomers exceeds what any single institution can achieve. You want to track a fast-moving object across the entire sky. You need observers at multiple longitudes. Amateur networks provide that coverage for free. The International Astronomical Union now has formal protocols for amateur discoveries. When Peter Veers detected 3i/Atlas, he filed a report through official channels. Within 6 hours, professional telescopes were confirming his observation. Within 24 hours, a minor planet electronic circular was issued, alerting astronomers worldwide. The system worked because it recognized amateur contributions as legitimate. Not second-tier, not preliminary, legitimate. And here's what this means for objects like 3i/Atlas, even if mainstream media ignores it. Even if institutional astronomy stays quiet, even if social media algorithms bury it, the discovery still happens. The observations still accumulate. The science still advances, because there are thousands of people out there who don't need CNN to tell them something is important. They can see it with their own eyes, through their own telescopes, in their own backyards. They're not waiting for permission to explore the universe. They're just doing it. And in doing so, they're quietly rewriting the rules of how scientific discovery happens. But this amateur revolution, empowering as it is, brings us back to a troubling question. If all this data exists, if all these observations are being made, if the science is advancing, why does the silence in mainstream channels still matter? Let me tell you about a young woman named Maria Gonzalez. In October 2017, she was a sophomore at Arizona State University. Undecided about her major, vaguely interested in science but not committed to any particular path. Then, Oumuamua happened. She saw it everywhere: news coverage, social media discussions, friends sharing articles about this mysterious visitor from another star. The possibility that we might have detected our first evidence of alien technology captivated her. She started reading more, watched documentaries, took an introductory astronomy course the following semester, just out of curiosity. That course changed her life. She declared an astrophysics major, graduated in 2020. Now she's a PhD candidate at Caltech, working on detection systems for interstellar objects. Her research could help us find the next Oumuamua, the next 3i/Atlas, maybe dozens more we're currently missing. When interviewed for a university newsletter in 2023, she said, "If Oumuamua hadn't been all over the news, I never would have taken that first astronomy class. I'd probably be in marketing or something. Instead, I'm helping design the systems that will discover these objects in the future." One person, one career, born from media coverage of a cosmic event. Now multiply that story by thousands. How many potential astronomers, physicists, engineers, how many future discoverers are we losing because 3i/Atlas never made headlines? How many young people who would have been inspired by this interstellar visitor will instead scroll past celebrity gossip and never realise the universe has just offered us something extraordinary? The cost of media silence isn't abstract, it's measurable in human potential. Studies from the National Science Foundation show a direct correlation between major astronomical events and STEM enrolment in universities. When the Hubble Space Telescope released its first deep field image in 1995, astronomy program enrolment increased by 34% over the following 2 years. When Curiosity rover landed on Mars in 2012, applications to planetary science graduate programs jumped 41% the next cycle. Media coverage drives awareness. Awareness drives inspiration. Inspiration drives career choices. Career choices determine who's working on these problems 20 years from now. And here's the more immediate impact funding follows public interest. We talked about this earlier, but let me make it concrete. After Oumuamua generated massive public interest, Congress increased NASA's Near-Earth Object Observations program budget by $65 million over 2 years. Not because the science changed, because constituents called their representatives asking why we weren't doing more to detect and study these visitors. That funding led to improved detection systems, better analysis capabilities, more telescope time dedicated to searching for interstellar objects. The very systems that eventually detected 3I/Atlas exist in part because Oumuamua captured public imagination. But 3I/Atlas isn't generating that same interest. So, when the proposed Interstellar Object Studies Initiative comes up for funding discussions again, and it will probably in the 2025 budget cycle, there won't be public pressure to support it. No emails to Congress, no social media campaigns, no evidence that taxpayers care, which means it probably gets cut again, which means when the fourth interstellar visitor arrives, maybe in 2027 or 2030, we'll have fewer tools to study it, less capability to respond quickly. We'll miss opportunities that better funding could have captured. The silence compounds. Each missed opportunity to engage the public makes the next opportunity harder to capitalise on. Think about what we're losing right now with 3I/Atlas. This object is revealing chemical signatures we've never seen before. Its composition tells us about stellar environments different from our sun's, the way it's outgassing, the molecules it's releasing, the variations in its activity. All of this is data about how planetary systems form in other parts of the galaxy. But without public awareness, without media coverage, without cultural penetration, this knowledge stays locked in specialized journals. A few hundred astronomers understand its significance. The other 8 billion people on Earth, they have no idea any of this is happening. Is that acceptable? Should profound discoveries about our cosmic environment be accessible only to experts? Some might say the science gets done either way. Does it matter if the general public knows about it? Yes, it matters enormously. Because we live in a democracy where scientific funding is determined by elected officials responding to constituent priorities, and those priorities are shaped by what people know and care about. When the public is disconnected from scientific discovery, they view science funding as discretionary spending nice to have, but not essential. Cut it when budgets are tight. Redirect it to more immediate concerns. But when the public feels connected to discovery, when they've seen the images, read the stories, felt that spark of wonder, they defend science funding. They view it as an investment in human knowledge, not a luxury expense. The James Webb Space Telescope cost $10 billion. Do you know why Congress didn't cancel it despite massive cost overruns? Because millions of people wanted those images. They made their desires known. They protected the mission through years of budget battles. That's the power of public awareness. That's what media coverage enables. And that's what we're losing when objects like 3I/Atlas pass through our solar system in silence. Here's another cost, harder to quantify but perhaps more important cultural perspective. Every time humanity confirms we're part of a larger cosmos that objects from other star systems occasionally visit our neighbourhood, it should shift how we think about our place in the universe. Oumuamua did that for millions of people. It made the idea of an interconnected galaxy feel real, immediate, tangible. Not science fiction, science fact. We're not isolated. We are part of a cosmic ecosystem where material flows between stellar systems across vast distances and timescales. That realization should change us. It should influence how we think about long-term planning, about our legacy, about what matters, when you understand that objects from other stars can reach us, that our sun's influence extends trillions of miles, but eventually gives way to interstellar space, that we're one small system in a galaxy of hundreds of billions. It provides perspective. But you only get that perspective shift if you know it's happening, if the discovery reaches you, if someone translates the science into meaning. Right now, in observatories around the world, astronomers are watching 3I/Atlas approach perihelion. They're collecting data that will be analysed for years, maybe decades. Future papers will cite these observations. The science will advance. But the cultural moment, the opportunity for this discovery to inspire, to educate, to shift perspective for millions of people that's slipping away, December 19th will come and go. The object will reach its closest point to our sun, and most of humanity won't even know it happened, unless something changes. Unless we decide that silence isn't acceptable, unless we recognise that how we share knowledge shapes what becomes possible. Because here's the final truth about 3I/Atlas and its media silence. It's not actually about this one object. It's about every discovery we collectively choose to ignore or amplify. It's about what kind of species we want to be, one that prioritises cosmic discovery, or one that lets the universe's greatest mysteries pass by unnoticed, while we argue about things that won't matter in 100 years. The choice, as it turns out, belongs to all of us, including you.